See, as usual, when we open the command MATLAB ID, then we are say the command window, current folder and workspace. Okay, from where we have to go to the current folder and select your folder, whatever you have saved the model. Okay, I have select this my folder where I have saved your project, and here is a MATLAB file where I show the your project MATLAB. So initially we have the three file. One is no Z source means only we have used the voltage source converter means inverter voltage source inverter. Second is Z source open loop. This Z source open loop means we are connecting the Z source, but this is open loop system. Okay, and another is Z source with a closed loop system. These are three system. So first we go for the first system. No Z source. This I have already explained to you. Once again, I have go through this first of all. It will take some time. Yes. First of all, I opened all the three file. Then for the second file also same. Now screen is visible. Yes.
Sir. Yes, sir.
Okay. See.
Diagram is visible.
Okay. This is the first simulation. No Z source. No Z source means without Z source inverter. Here. So this is the DC supply we have provided. DC supply of 400 volt. We have taken the reference from their base paper, whatever I have sent to you already. And after that, we have connected here that inverter, voltage source inverter, which is having six switches S1, S2, S3, S4, S5, S6. And we have to provide the gate pulses to this each switches of inverter. G1, G2, total six gate pulses we are required, connecting G1 to the G1, G2 to the G2, and G3 to G3. This sinusoidal pulses we are providing to this G1, G2, and G3. We total six pulses we are providing. This is a go-to block. Same block here. You see this is a from to. This block is called from to. G1 is mentioned. This is go-to block. Go to. So whatever the signal, whatever the pulses is generated here using the sinusoidal pulse width modulation, That same pulses is goes to the G1, G2 and G3. Then after that, this inverter is turned on and it provides the supply here. When we provide the pulses, you have to simply, you should know the working of voltage source inverter. You might be studied in power electronics, voltage source inverter, how it works. So this output we are getting get through this inverter when we are providing the gate pulses through this sinusoidal pulse width modulation. After that, this is a voltage measurement block. Voltage measurement block A, B, C is there. We can measure, sorry, voltage and current we can measure. If you see here, there is a voltage and current option. If you zoom out this, then you will clearly see this. This is voltage VABC, three-phase voltage and three-phase current we can measure here. Three-phase here. This is a mux. Mux means single input and many output. This block, if you click on this block, if you click on this block, if you click on this block, this is the mux blocks. We have provided one input and we get the many output. Three output we are getting where we measure the current of voltage of each phases VA, VB, and this is VC. And here is a current IAVC inverter output current. After this is supply. This is for measurement purpose only. Okay. This blocks. If you see this block voltage with scope, this is measurement purpose voltage and current. You can connect it like voltmeter, multimeter. We have connected in the circuit. Same. This is voltmeter, voltage and current measurement block. And here we can see the waveform in scope. Always we have to see every waveform in the scope. Okay. Now this is the induction motor, and you have to provide the three-phase supply to the induction motor. And here same any motor in MATLAB we cannot connect it any load. So what we have show here, we have show simply the torque, mechanical torque, 10 Newton per meter 10 Newton per meter square. You can change 5, 6, 7, 8, 9, 10, whatever you require according to our requirement. This is load torque, mechanical torque we are providing here. After that, if if the proper signal goes to the inverter, output of inverter to the motor, then we can see we can observe the waveform of motor also. And this motor waveform, if you see here, this is again same mux type measurement block. We have connected a mux here, single input, many output. Here we measure the speed, and here we measure the torque. Speed and torque we are measuring this scope, speed and torque of the induction motor we measure on this scope. This is workpiece block. When you open the second model with the jet source converter and then comparison done. So for that purpose, comparing this value with next result, we will use this block, workpiece block. So in that case, there is no use of this workpiece, but in second model, if you run this second model, then this block will helpful. Okay. If you remove in this model, then also okay. But if you have to run second model, and at that time this block is required for comparison purpose. Okay, we will see how this is useful in next simulation. Now simply run this model. You can run this model by clicking, by double click on this by run, which is available on the top. It will take time. You have set the time of 1 second. If you say 2, 3, 4, 5, it will take the much more time, simulation time. This we have set always 1. You can set also 2, 3, 4, 5, but it will take a lot much time. Okay. It is in process now. You can also click on this while running also. You can observe the waveform. If you click on scope, you will get the waveform. See, if you see the scope, here you see the waveform observation. How much speed we are getting? This is the path we are completing. Here is the top, and this is the speed, and this one is torque. Have you seen that is speed and torque waveform? Yes,
Yes, sir.
yes. If this is torque and speed waveforms. Okay. It is approximately how much? If you see the speed is of how much? It is a 1500 RPM. But speed, if you see that speed, there is a lot many disturbance. Not proper. We are not getting the smooth speed. There is much more. Also torque and also initially it is very high, up to 200 Newton per. After that it will set to up to 10. How much torque we are providing? 10 Newton meter per square mechanical torque we provide. So we get the electrical torque also same near about 10. But again, you see there is a lot many distortion. It is 10, but lot many distortion. And this waveform. Now, you have to again check it. You just make it, just click on this. You can also zoom out. If you have to zoom out, you just click on this plus. If you have to zoom out x-axis, you click on this. Y-axis, simply you turn this. You can observe this for every second you can observe. But there is no need. It is very in second you can observe. Just like this, you are getting. This is very second. So you can also observe the x-axis if you have to zoom out like that. But there is no need. But some time we require to observe. Some project we need to means observe this waveform also. But yet in that project, there is no need to observe. Okay. Now, this is about the second, this no jet source. Then after that, jet source with open loop. Now we are connecting the jet source. But again, it is open loop. Means whatever previously we have seen, there is no closed loop operation. In open loop, simply we have connected, we have not taken any reference from the output. We directly provide the supply. Same supply you see here, same connection. This is a DC 400. What is your observation? Here we connect the JSON network. Here we connect the,
The diagram is not visible.
yes. Okay.
Diagram is not visible.
See, now
No,
visible?
sir.
Yes. Now with this waveform with Z source but
Yes.
open loop. Z source with open loop network. Okay. So here what is the this same voltage we are providing here, same inverter. Okay, same thing we are providing, but this is the Z source network. Z source network we have. provided initially. Okay, this voltage source inverter here and J source network. That's why it is called as the J source inverter. J source inverter. Say output we are getting here. This voltage measurement block. Output goes to the motor. When the signal is goes to the IGBT of the inverter, then inverter will turn on and it provide the output supply to the motor. Here is also scope and this measurement block. Same thing you can see here, 10 Newton per meter torque is here, and we observe the speed and this.
Not audible, sir.
Yes,
Yes, now audible.
here now you can run here this model. You have to observe the same this speed, torque, as well as voltage and current of the inverter.
Sir, sir,
Yes,
please repeat open loop.
simply you have to what you have to run this model. Only we have connected here. If you see the difference in previous and this model, what is the difference you have observed? You have observed we have connected only JSON network and remaining is very same to the previous model. Okay, remaining is very same. Only we have added JSON inverter. If you see the base paper also, we have added only the JSON network here. Okay, and run. Previously whatever I explained, same model is here. Same thing is here, same inverter is here, voltage source is same, motor is same, this measurement block, and this is also G1, G2, and this control. This is control techniques, control strategy, sinusoidal pulse with modulation technique we have provided to the inverter. Okay. Now you have to run this model. It is in process. Okay.
Sir,
Okay.
what the name of that is we can see G1, G2, G3, G4. What we call
The G1, G2, G3, this block is a go-to block. This G1, G2, this is all this go-to block, and this is a from to block, this from to block, this called as a from to block. If you double click on this every block, there is a name is given. Okay, what is the this go to and this from to, but same you have to mention the same G1 here, here also you have to mention the G1, here also you have to mention G1, here G2, G2, then whatever signal you provide here, same signal will come to here. Okay, same. We are why we providing these types of G1 and G2 this block in some application.
I have asked you, sir, that I have asked you that G1, G2, G3, G4 we connected, right? Then what we call the circuit or the switches?
Yes, this switches.
No, sir,
Yes.
G1, G2, upper one,
Yes, yes,
upper one.
this.
Huh. The entire circuit name, sir. The entire circuit name. What we call the entire upper circuit?
Yes, this is your control circuit. This is control circuit.
Okay, sir.
Now we have run this again. You have to check the waveform on this. See, now this is a waveform. After we are connecting the gate source, you see the waveform here? Yes.
Yes, sir.
Yes, they see it is smoothly compared with the previous waveform. It is very constant waveform we are getting, and torque also somewhat getting the constant. It is approximately how much? It is 10. It is 10, and speed you are getting how much? 1500 RPM. So what you observe, if the both the modeling you have seen that after connecting the JSON network and without JSON network, that we are getting the constant and very ripple free output, and there is a very less ripple in the speed as well as in torque also. Now, if we click on this scope to block on the simulation, again we go for the simulation. Here is a scope to block. Scope to block. Where we observe the this no here you see this is the workspace block. Here you mention and no jet source means previous waveform of speed. Here we observe, and here is the previous waveform of torque where we observe, and same this after connecting the jet source and without connecting the jet source speed. Here is after connecting the jet source torque and without jet source torque you can observe, and same it goes to the scope. Means comparative analysis we are observed in this scope. Comparative analysis we can observe. Clear it. Just I click on this scope, double click on this globe. See here, you have you seen that there is another comparative waveform you have seen here. Have you seen this comparative waveform? One is shown by the blue line and another is brown line. Yes.
Yes, sir.
Yes. See here again. What is your observation? This blue, whatever the blue line show here, this is a without jet source, and this one you see here with a brown line. This brown line show with n with jet source. N with jet source means speed with jet source, and this blue n with no jet. Similarly, torque T no jet source and T with jet source. So which one is better? Which one is better? If you do the comparison, which one is better? Yes, without jet source or with jet source?
Speed with jet source.
With the jet source, we are getting the very smooth waveform, and without that, torque is also smooth. Now, third model, we'll go for the third model, which is jet source closed loop. See here, this model is visible now. दिख रहा है आपको? Yes.
Yes, sir. Yes, sir.
Okay. देखिए, see here. Now here we use the closed loop system. Again, it is a you see here the DC source, the Z source inverter, Z source network, and this is inverter, this motor, and after that we have measure here speed and torque. This speed and this is torque measurement block. Okay. Now here you observe that or we are using the closed loop control system. Means closed loop means what? Why we are open loop and closed loop? We know that what is the advantage in open loop and closed loop. So closed loop was always beneficial. But whatever we set the reference speed, same speed we can get the output side also. Okay. Here we have taken reference as a speed. We have taken the reference as a speed. See here from this is a speed wire you can see here. This is speed wire. Output of motor is speed. Output motor speed. This is N, and we have taken this connected this speed bulb. This is speed line. See here speed line we have connected. Have you seen this is the speed line? Yes. Which is connected to the this
Sir.
gain block gain block here. This is minus, and we have taken the reference speed. This step means here we have put some value. Step means we have put some value here. You can put the constant value as well. Simply if we click on this step here, we put the value. Initial is at 1500, and then final value is how much? It is 1000. See here? Yes. यहाँ पे दिख रहा है आपको?
Yes, sir.
Yes, when we this speed we have taken the speed as a reference. See this control आपको थोड़ा समझना पड़ेगा एक बार. Okay. Here we have taken the speed. Closed loop for reference we have taken the output speed, and according to taken the reference as a output speed, what we have generated the this gate pulses. See, this is the gate pulse. This signal goes to here, and after that, this gate pulses is generated. Initially, we have what we have given only we have given the sinusoidal pulse width modulation technique. We have provided here sine wave, and this open loop type system we have provided. But now we have taken the reference as a speed, and we have used the closed loop operation. This taken the output speed, and we have given the reference speed whatever we required. I have said initially it is how much 1500. Then after 0.5 second it is 1000 RPM. Okay. You can set also constant. You can set constant also here. You use the constant block. Here I use the step block. There is you can use the direct constant block also and initiate the 500, 1000 and 15 RPM also, whatever you require. But for dynamic operation, I have shown here 0.5. Means initially it is 1500 and after 0.5 second it is a 1000 RPM. Okay, we have taken the 1 second as a time reference. For 0.5, initially it is a 1500 value, but after 0.5 second it is 1000. Okay, it will change the speed. Okay, and according to that, this sig output is goes to the PI controller. Okay, which minimize the error. This saturation, dynamic saturation block is here. Okay, which just use if you are remove this block also, there is means there is nothing will happen and no effect will observe. But just for the we have put some value, saturated value here in point, very point. Okay, then after that we have taken the this frequency This signal is generated from this, it is the F, okay, and this goes to the this function F1, F2, and F3. Again here within the gain value, and it goes to the this. Okay. Now this control circuit diagram is available in the paper. Okay. This control system diagram is available in paper, and this same same block we have drawn here. We have closed loop operation we have taken as a reference. Now you can see, you can see, you can see. You run this and observe the result also. If you run this now, just I run this and check the output, how we are getting the voltage and current. This I have just, have you seen the scope? Yes. Waveform visible to you?
Yes, sir.
Okay, now see here at
Yes, sir.
0.5 second, at 0.5 second it will drop. At 0.5 second, the speed will change. Initially, how much? If you see, initially it is a near about 1500. This is 1500. But at 0.5 second here, it will change to whatever we have set here, up to 1000. Yeah, it will go slowly, slowly. It will maintain the 1000, near about 1000, whatever you have set RPM. Have you seen here? Yes.
Yes, sir.
You see, so it meant it 1000. What? Why? Because we have taken the reference speed closed loop operation. Whatever we provide, what is your requirement according to it will generate the output. But in open loop, this facility is not available. But in closed loop, these types of the facility is available. Whatever we have provided in the reference, same we are getting at output side also. Initially, it is a how much 1500 RPM, but after 0.5 second, it will drop to up to 1000. Why? Why? Because we have given the closed loop. In closed loop system, we have given the reference like that. It should be changed. If the here is also see initially the torque initially how much the torque also maintain, but when the speed it drop, torque also change, and again it may try to maintain the same value. Okay, it try to maintain. Okay,
So torque is depend on the value of speed.
yes.
So torque waveform depends on the value of speed we applied.
It will drop. It is depend upon the torque value. Depend upon the mechanical torque whatever we provide. Initially, how much we are providing the value 10. Mechanical torque, how much we providing 10. So it will also maintain 10. But when the speed is drop, it will transient. There is a sudden speed drop. There is also electrical torque also change for that value. Then after that it is maintain again same value. Okay. There is not drop again. It is maintained to the near about 10 value. But initially when we suddenly any changing the speed, so some maybe effect is observed for initial value. But after that it is maintained to the After that, it is independent on the speed. Okay.
Okay.